So this is the first page for trig. And the first question says, which of the following trigonometric functions has the longest period? So I'm going to start with the easiest ones to read for that. So I think the graph is pretty easy because I can just trace out to figure out how long the period is. Now I can't tell exactly how far out it goes, but if I went from here and traced this period kind of going in each direction, it looks like that goes from -6 to +6. So that shows a period of 12 to repeat the cycle. So we'll write that one there. Maybe I'm going to do the table next. So let's say that one looks the next easiest. So here I'm starting at 0. Actually, we'll start here, 0, 0. So this one, if I was going to graph it, goes down, up to 6, and back to here. Okay, and it takes from 0 to 4 pi to do so. So if I type 4 pi in my calculator, I get 12.56. So right now it looks like 4 has a longer period than 3. For number 1, I can use the period formula. So that formula is 2 pi over b. In this case, b is pi over 4. So that's going to be 2 pi times 4 over pi. Pi's cancel, so this one has a period of 8. Okay, so right now it looks like this one is still winning, so we're going to cross out number 1. So the last one, we have to read a verbal description and graph it. I'm just going to draw a little graph here. So I have the 0.56. We'll say that's somewhere around here, not perfectly to scale. That's the maximum. It goes down to 8, -1. So that means it would come back up to the top and finish one period out here at 11.6. It's pi, not an 11. Let's erase that. $11.6. So we're going from 5.6 to 11.6, so that has a period of 6 from the 5 to the 11. So still number 4 is the one with the 12.56 is the period as the longest period. The next one says sine is 7/25 and the angle is in the second quadrant. So I'm going to draw an angle in the second quadrant. Remember, we draw a reference triangle and theta is always between that triangle and the x-axis. So from here, this is opposite over hypotenuse, 7/25. I do a quick check and both of them are positive because this one goes up and we know the hypotenuse is always positive. To get the third side, so I can find tangent, because tangent of theta is opposite, which is 7 over adjacent, but I have to find that side, so we'll do a Pythagorean theorem. So 7 squared plus x squared equals 25. 25 squared. If I solve this, I get x equals 24. Now, because this is going backwards, I need to use -24. So that's what I would put down here. Remember, the directions determine the signs of x and y. So the answer is -7/24. The next one is kind of similar, but we're going to start with a circle. It says a circle centered at the origin has a radius of 13 units. So we'll draw that in. This is not the unit circle because the radius is 13 units. The terminal side of an angle theta intercepts the circle in quadrant 3 at point C. So again, we're going to draw that reference triangle. The hypotenuse is 13 this time. We always keep that positive, and that's from the radius. The x is -5. So if I do Pythagorean theorem to find the third side, I'm trying to find sine of theta. So here is my theta. That's opposite over hypotenuse, so I need to find this opposite side. I'm actually just going to label it with y because it's the y value. So I have Pythagorean theorem, 5 squared plus y squared equals 13 squared. If we solve that, we would get 12. The y is going down, so I need it to be negative. So the sine value, that's negative, kind of blended in with the equal sign. Opposite is -12. Hypotenuse is 13, so that's going to be choice 3. So on the next one, we have a graphing question that seems like it's a sign question, but really it's a transformations question. And we're saying, how do we go from 3 sine x to 3 sine x minus pi over 6 plus 4? So when we have x minus, we know that that's going to move the graph to the right. and specifically right pi over 6. When we have a plus at the end on its own, we know that's going to move the graph up that many units. So looking at this, we want right pi over 6 and up 4, and that is choice 1. The next one is also about trig graphs. It's kind of a tricky question. It says a sine function is increasing through the origin and can be used to model light waves. Violet light has a length of 400 nanometers. Over which interval is the height of the wave increasing? So wavelength is actually a fancy word for the period of the graph. And it's really hard to know what they're going to put on the regions in terms of like what context you have to know. I think even when you see the word wavelength, like the period is the only thing we think of that really has a length. So I'm going to draw just a basic sine curve. I don't have other information. It says the period is 400, and we want to know where the graph is increasing. So our choices are from 0 to 100 or 300 to 400. So the only choice I see there of those two, right, this piece of the graph is increasing, so it's from 300 to 400.